Welcome to Data Strategic Advantage channel. Our topic today is data integration. We're constantly hearing about how crucial data is for businesses. But it's not just about having tons of information, it's about making that information work together, right? That's where data integration comes into play.
Yeah, exactly. Think of data integration as the process of taking all the different pieces of information an organization has, spread across various systems, databases, and even departments, and making them a cohesive whole. It's like taking scattered puzzle pieces and assembling them into a complete picture.
So it's not just about moving data from one place to another within a company, but also connecting data between different organizations.
That's right. And the goal is to get that data into a consistent format. This can happen physically by combining the data in a single location, or virtually by creating a unified view. So it appears integrated even if it resides in different systems.
It's like if different teams are using their own jargon, data integration provides a common language they can all understand.
Exactly.
And that leads to data interoperability, which is just the ability for those different systems to communicate and share information effectively. Precisely. They need to be able to not only exchange data, but also understand the meaning of that data. This ability to integrate and interoperate is fundamental for so many everyday data management tasks that organizations rely on, such as migrating data to new systems, converting it into different formats, or simply enabling different applications to work together seamlessly.
Those foundational tasks make perfect sense. But it's also critical for more advanced functions like data warehousing and business intelligence.
Absolutely.
Fundamental. A data warehouse, for instance, acts as a central hub for analyzing data from various operational systems. To build that hub, you need robust processes to pull data from those sources, clean it up, transform it into a consistent structure, and then load it into the warehouse. Business intelligence tools then tap into this integrated data to generate meaningful reports and insights. Similarly, in areas like reference data and master data management, where the focus is on maintaining consistent and high-quality versions of core business entities like customers or products, data integration is the essential engine that feeds these systems.
Okay, we've established what data integration is and how it works in a general sense. But let's dig deeper into the why. Why is it so crucial for organizations in today's environment?
Well, the key shift is that organizations now recognize data as a really valuable asset, on par with their financial or human capital. But simply having data isn't enough. To truly extract value, to gain insights, make informed decisions, and drive innovation requires deliberate effort, careful planning, organization-wide coordination, and a strong commitment. Data integration is a cornerstone of making that happen.
So it's more than just a technical necessity. It's directly linked to achieving business goals.
Exactly. Stakeholders across different parts of the business expect the organization's data to be coherent and consistent when they look at different reports or interact with various systems. The information about a customer or a product should align and make intuitive sense. Broad usability of the data is a key expectation.
And I can imagine that's not always the reality.
Right. Different departments likely have their own unique ways of defining and tracking the same information. Precisely. Marketing might define a lead in one way. Sales might have a different criterion for a qualified prospect. And customer service might track clients with yet another set of attributes. While they might all be referring to the same individuals or entities, their representations differ. These variations, whether subtle or significant, create major hurdles when trying to get a unified view of the business. Data integration is designed to bridge these representational divides.
Okay, we understand the why. Now let's talk about the fundamental how. What are the essential processes involved in making data integration happen?
At its core, data integration typically involves three key stages, often referred to collectively as ETL: extract, transform, and load.
Let's start with extract. What does that involve?
Extract is the initial step of identifying and retrieving the necessary data from various source systems. These sources could include anything, from traditional relational databases and cloud-based SaaS applications to older legacy systems and even simple flat files. You're essentially pulling the raw data you need.
Got it. Gathering the raw materials, what comes next is transform, which sounds like where the data gets shaped.
You're right. The transform stage is where the extracted data is manipulated and converted to be compatible with the target data store. This is where a significant amount of processing can occur. For instance, you might need to reformat the data, converting date formats or standardizing text encodings. You might need to restructure it, combining information from several fields into one, or splitting a single field into multiple. Data cleansing is also a critical part of this stage, where you identify and correct errors, inconsistencies,
Right.
or irrelevant data. Additionally, you might be routing data to multiple different target systems, or even using the transform data to trigger specific actions in other applications.
That's a comprehensive step. So it's not just about moving data, it's about preparing it for its destination. And finally, load is simply moving the transformed data into the target system.
Exactly. Load is the final stage where the prepared data is moved into the designated target, which could be a database, a data warehouse, a data mart designed for a specific business unit, or another application altogether.
Okay. ETL. Extract, transform, load. That's the fundamental process. Now, when we consider when and how often this happens, I know there are different approaches. Can you outline some of the key timing and methods of integration?
Certainly. One of the longest standing and still prevalent methods is batch processing. This involves moving large volumes of data at scheduled intervals, perhaps daily, overnight, weekly, or monthly. The timing of these batches is crucial to minimize disruption to operational systems and to ensure you have complete data sets available for reporting and analysis when needed.
So it's like a scheduled data delivery service. What's a more immediate alternative? I've heard about change data capture.
Change data capture, or CDC, offers a more efficient approach in many scenarios. Instead of transferring the entire dataset each time, CDC focuses on capturing and transferring only the data that has changed since the last integration. This can lead to significant reductions in bandwidth and processing overhead. There are primarily two ways to implement CDC. Log-based, where you essentially monitor and process the database's transaction logs to identify changes, and trigger-based, which often requires modifications to the source application to explicitly track and signal data modifications.
That sounds much closer to real-time updates. Are there even more immediate methods for integration?
Yes. For applications requiring the most up-to-date information, we have near real-time and event-driven integration. Near real-time aims for a minimal delay between a change occurring in the source system and its reflection in the target. Event-driven integration takes this further. When a specific business event happens in one system, it automatically triggers updates or actions in other connected systems. This can involve tightly coupled systems where an immediate update in one triggers a direct update in another, or more loosely coupled approaches utilizing message queues or an enterprise service bus, which we'll discuss shortly.
Okay, so we have different speeds of data integration to match different needs. Now, how do these various systems actually connect and share data? What are some common architectural patterns for data integration?
One of the simplest, but often the most challenging to manage as the number of systems grows, is the point-to-point pattern. This involves establishing direct connections between individual systems that need to exchange data. While straightforward for a small number of integrations, it can quickly become a complex and unwieldy web of connections, making maintenance and troubleshooting difficult. Imagine trying to manage direct phone lines between every employee in a large company. It will become chaotic very quickly.
That tangled web analogy really hits home. What's a more structured way to manage these connections?
A more scalable and maintainable pattern is the hub-and-spoke model in this architecture. You consolidate shared data in a central hub. This could be a data warehouse, a more focused data mart for a specific business area, or a master data management hub for core entities. And then various applications connect to this central hub to access the data they need. This significantly reduces the number of direct connections required and minimizes the impact on individual source systems. Adding a new system simply involves connecting it to the central hub.
That sounds much more organized, like a central data exchange.
Yeah.
You also mentioned something called an enterprise service bus.
Yes, the enterprise service bus, or ESB, is another architectural pattern, often employed for enabling near real-time data sharing and communication between applications. Think of an ESB as a central communication infrastructure, a software layer that allows different applications to interact and exchange data using standardized protocols and messages, regardless of their underlying technologies. This promotes a service-oriented architecture where systems are more loosely coupled, meaning they can interact without needing deep knowledge of each other's internal workings. It acts like a universal translator and message router for your applications.
So it provides a standardized way for different applications to talk to each other. Now, before any of these integration efforts begin, it seems like careful planning would be essential.
Absolutely.
What's the importance of planning and analysis in data integration?
It's absolutely critical. You can't just start moving data without a clear understanding of what you're trying to achieve and why. Defining your data integration requirements involves thoroughly understanding the business objectives, identifying the specific data needs of different stakeholders across the organization, and being aware of any relevant legal or regulatory requirements that might govern your data.
So it's not purely a technical undertaking. It's deeply intertwined with business strategy and compliance.
Precisely. You also need to conduct a thorough analysis of your existing systems and the data they hold to determine the most appropriate integration approach. Factors such as the volume of data, how frequently it changes, the complexity of the required transformations, and the number of systems involved will all significantly influence the choice of integration patterns and technologies.
Okay, the planning is done, and the architecture is chosen. Now comes the actual building of these data pipelines. How do you typically develop and manage these data flows?
Integration or ETL data flows are commonly developed using specialized data integration tools. These tools often provide user-friendly graphical interfaces and pre-built components that simplify the design and construction of these pipelines. For batch data flows, you'll typically rely on enterprise scheduling tools to automate their execution, allowing you to define the order in which they run, their frequency, and any dependencies between different flows. And as we touched on with interoperability, you might also need to create specific mappings between different data stores to ensure that the data is correctly interpreted and translated as it moves from source to target.
No. With all this data movement and transformation happening, how do you keep track of it all? That's where metadata plays a crucial role.
Absolutely. Metadata is indispensable in data integration. It's essentially data about data. Metadata repositories serve as central catalogs for documenting the technical aspects of your data, its origin, structure, and destination, as well as its business context and meaning. Information such as transformation rules, data lineage, which tracks the journey of data from its sources to its final destination and any transformations it undergoes along the way. And the schedules for data processing are typically stored in these repositories. Think of it as the comprehensive documentation for your entire data integration landscape.
It's like the blueprint and the historical record for your data.
Exactly. Effective metadata management is key to understanding where your data comes from, how it's being used and modified, and it becomes increasingly important as organizations engage in more complex data integration initiatives, including data sharing with external partners.
That makes perfect sense. Now, data integration inherently involves handling data. So how does it relate to data quality? Can integration processes help improve data quality, or can poor quality source data negatively impact the integration?
It's a symbiotic relationship. Data integration processes can definitely contribute to improved data quality. For example, the transformation stage often includes data cleansing steps to identify and rectify errors, inconsistencies, and inaccuracies, thereby enhancing the overall quality of the integrated data. However, if the source systems contain significant data quality issues to begin with, those issues can certainly complicate the integration process and potentially propagate errors into the target systems. Therefore, understanding and addressing data quality in the source systems is a critical prerequisite for successful data integration.
So it's a case of garbage in, potentially process garbage out if you're not careful.
Yeah.
Makes sense. Finally, when dealing with important data and integration processes, are there certain expectations or guarantees that need to be in place? That sounds like the realm of service-level agreements.
Exactly.
Yeah.
Establishing service-level agreements, or SLAs, for data integration is important, particularly in regulated industries or when dealing with sensitive information. These agreements define expected levels of performance and reliability for your integration processes, such as the anticipated uptime of integration pipelines, the expected latency for data delivery, and other key metrics. They set clear expectations and provide a framework for managing the performance and dependability of your data integration infrastructure, ensuring a certain level of service and accountability.
So it's about setting and meeting standards for your critical data pipelines.
Precisely.
Well, this has been an incredibly insightful deep dive into the world of data integration. It's clearly a fundamental building block for any organization serious about leveraging its data effectively.
Absolutely. A solid understanding of the various approaches, the critical importance of thorough planning and analysis, and the vital role of metadata management are all essential for successful data integration initiatives.
And by implementing the right data integration strategy, organizations can significantly streamline their processes, enhance their data quality, and ultimately drive much more informed and effective business decisions.
Couldn't agree more.
Don't forget to subscribe, and don't hesitate to tell us in the comments what topics are important for you.